Hey everybody, Miss C here. This video we are going to learn about mixtures, solutions, and water. So first I'm going to start by talking about mixtures. A mixture is when multiple substances are combined. And we can either have a mixture be considered homogeneous or heterogeneous. Homogeneous and heterogeneous are probably words you've heard before. Homogeneous means that it looks uniform throughout, so you cannot see the different substances that are being combined. And then heterogeneous means that you can see the different substances. So an example of something that's homogeneous, remember homo means same. Something like that would be vanilla ice cream. We can't see the different parts. It's just all white throughout, or like plain chocolate ice cream looks all dark, chocolate colored, brown all throughout, right? We don't see the individual milk, sugar inside of it. Whereas something like cookie dough ice cream, I can see my individual cookie dough pieces, and because I can see the different pieces, that's considered heterogeneous. Hetero means different. Okay, so mixtures, I can have different special types of mixtures. And my different types of mixtures I can have a solution. A solution is a homogeneous mixture where particles are dissolved in the solvent. That means that my particles dissolve in my solvent. My solvent is usually something like water. So it's some sort of liquid typically, and that's how we'll interact with it. To separate the different substances, you have to evaporate the solvent to leave the dissolved substance behind. So for example, if I had salt water and I wanted to get the salt back out of my water, so I dissolve my salt in my water, it mixes and it looks like it goes away. It doesn't really go away. It's just dissolved. The salt molecules or the salt compound has been broken apart into its ions and it's dissolved and I can't see it anymore. But if I evaporate off the water, so I boil the water, just let my cup of salt water sit out, eventually my water will evaporate and I'll be left with salt crystals in my cup that I had. So we can separate it back again by evaporation. A colloid is something you might not have heard of before. It's a homogeneous mixture where tiny particles move around that never settle. Okay, so they just kind of like mix and float about in my mixture, but they never settle, and you might think you can see different parts, but you really can't. It looks pretty uniform throughout because the particles are so tiny. To separate, you could use a really fine filter, or like before, we could evaporate off the solvent. So it's kind of this middle ground. All colloids exhibit something called the Tyndall Effect, which is where light is scattered by tiny particles. And that means if I were to shine a light through a colloid, my light would scatter. So an example of a colloid is fog. So most of you are starting driver's ed or a finished driver's ed, right? This is the year that most of you get your driver's license. And fog, we know that when we're driving in fog, we can't use our brights or our high beams. We're supposed to use our low beams. And then some people also have fog lights on their cars, which are really close to their running boards, on the bottom of their cars. And that's so it illuminates the road, but nothing else. Because we know that when we have our lights on our cars, that if we have our brights on, it scatters the light everywhere and we really can't see. And that is the Tyndall effect in action. So the next time you're driving and your parents or whomever you're driving with turns on their brights and it's foggy out, you can say, that's the Tyndall effect, because you have a colloid and you're driving through it. Next, we have a suspension. This is a heterogeneous mixture. So now look, this is different. Heterogeneous, whereas the last two are homogeneous. A heterogeneous mixture with small particles that move around are big enough to settle. So I could shake up my suspension and it'll all mix together. I can see the different parts like swimming around in my water. And if I let it sit, eventually it'll settle out. Okay, so this is something like dirty river water, right? It's muddy, there might be algae in it. And when I mix it up, they all, move around and mix together. But eventually if I let it settle, my dirt's going to settle to the bottom. So to separate that, we can filter out our suspension. So we can pour our suspension through a filter, and then whether that's a thick filter or a really fine filter, and it'll catch my small particles, and then my solvent will come all the way through. So let's look more closely at solutions. Solutions are made up of two parts, and the scientific way to describe those two parts is the solute and the solvent. And I've kind of referenced those terms a little bit so far. The solute are the particles that are dissolved in my solution. So if we're thinking about our salt water again, my solute would be the salt. Whereas my solvent is a substance in which the solute dissolved. So in our case, for my salt water, that would be the water. We like to say that the solvent dissolves the solute, or the solute dissolves in the solvent. So the solute gets dissolved, the solvent's the one that actively dissolves the solute. We have something called a universal solvent, which is water. And we talked about before how for most of our solutions, we're going to have water be our solvent. And that's because water has some really great properties that we're going to take advantage of when we make our solutions. Water is special. Without it, we wouldn't exist. And because of the unique properties that it has, life as we know it is real, right? It exists. Water is made up of two elements, hydrogen and oxygen, and they're chemically bonded together to form a molecule that looks like this. So if I were to be able to zoom in really far and see the actual elements and atoms of hydrogen, oxygen, and hydrogen, right? We know water is listed as H2O. That's two hydrogens here and here, and one oxygen here. And my hydrogen and my oxygen are bonded together. They share electrons back and forth. And oxygen also has two more pairs of electrons out here. So oxygen has most of the electrons, and hydrogen really doesn't have any. It doesn't really want any, so it doesn't really have any. And one of the things about water, its special properties, is it's considered polar because it has poles, right? Just like a magnet would have a positive pole and a negative pole, or the earth has positive and negative poles. Our water molecule can also make positive and negative poles. At the oxygen, it has most of the electrons. We know that electrons are negatively charged. So this we say is our partially negative end. And then our hydrogens, because they don't have any of our, they really don't have most electrons there. So we say that that's the positive end. So we end up with it almost like a magnet where there's positive ends and negative ends. And that's going to come into play here in a minute. All right. Water has unique properties thanks to the way that the molecule is made. So the water molecules interact with each other. Because of that, at room temperature, they're a liquid. Water has unique properties as a solid. The water solid is ice. We have a fancy name for it. And ice is actually less dense than liquid water, which is the opposite of everything else. Everything else, the solid form, would sink in the liquid form, but not water. And thankfully, because otherwise, like I said, we wouldn't have life as we know it. Two properties that we're going to explore a little bit more, adhesion and cohesion. Adhesion is the attraction between a water molecule and another object. Cohesion is the attraction between water molecules. Okay, think of like you cohabitate with somebody, you interact with another person that's like you. Adhesion is with another, so add and another, right? Both start with A, so that's how we can remember the difference. And we'll do an activity where we look at adhesion and cohesion and see how water interacts. We also know that water is a great dissolver, right? It's called the universal solvent for a reason. It's really good at dissolving things. So water molecules, like I said, have a positive and negative end, just like a magnet, that can easily pull apart other substances who have positive and negative ends. And we're going to look at that here when we look at dissolving a little closer. So dissolving can happen in two different ways. We can have dissociation and dispersion. We'll look at dissociation first. It's a process in which an ionic compound, so that's a compound with positive and negative ends, is separated into ions, and ions are charged particles. Water pulls those ions into solution. So we have our water molecules, right? We drew those before. And then we have something like table salt, sodium chloride. Sodium, when it becomes an ion, is a positive charge. Chlorine, when it becomes an ion, chloride, has a negative charge. Okay, so my water molecule, we know that the oxygen has a negative charge. My hydrogens are positive. And my other one, right, negative oxygen, positive hydrogen. So what happens is that my partially negative part of my water is attracted to my sodium ion. And so my water molecule comes in and pulls my sodium ion off. At the same time, my other water molecule, that's positive end, comes into contact with my chloride ion and pulls it off there. So one comes in from one side, the other comes in from the other side, and they attract onto it, and then they rip it apart. Okay, so it's actually kind of a vicious cycle, right? It comes in and just rips them apart. Dispersion is a little less crazy. Dispersion is where water just comes in and pushes apart another molecule. So these little guys are my water molecules, and this is some compound. And my water molecules come in and they just kind of like wiggle their way in between and push these guys out. Okay, so it's kind of like if you were and another person were sitting on a couch and somebody wanted to squeeze in and they come in and they kind of sit between you and like wiggle themselves down in between you two on a couch, right? That's dispersion. They're dispersing you apart. Or like if your teacher said space apart, social distance, right? That's dispersion. We're pushing people apart from each other. Okay. Another thing about dissolving is we can say that like dissolves like. You might hear that. And that just means that something that's polar dissolves polar and nonpolar dissolves nonpolar. Something that's polar is water. Something that's nonpolar, the opposite of polar, is oil, right? We know that water and oil don't mix. But things that are like water can dissolve in water, and things that are like oil can dissolve in oil. So for a substance to dissolve, it has to be similar. So for something to dissolve in water, it must be similar to water. There are a couple of factors that affect how quickly something can dissolve, or rates of dissolving. The first one is surface area. If I have a high surface area, it's going to dissolve faster. So that means that if I have something that's crushed up, as opposed to being in chunks, the crushed version is going to dissolve quicker. Okay. That's like just powdered sugar versus a sugar cube or a rock of something, right? If I have smaller pieces, it's going to dissolve. Crushed ice dissolves faster or melts faster than solid ice. Stirring. If I stir, I'm going to move my particles around. I'm going to agitate them. They're going to move around faster and faster. When I mix my solute, my solvent, they start bombarding into each other more. They're going to be able to interact, and water can pull them apart or get between them and push them apart. Okay, so that's really like bumping them into each other. And then finally, heat. The more heat that I have on something, the faster it dissolves, because molecules move faster at hotter temperatures. Heat is directly proportional to how much energy something has. And so if it's hot, it's going to have more energy. It's going to move around more. And then if it moves around more, it's going to bump into each other more. And more colliding equals more dissolving. So in the next coming days, we're going to explore water solutions, mixtures, and look at some of the different properties. And we're going to look at filtering and separating. And we're going to have some fun. So thanks for listening. And I will see you guys all tomorrow.